Okay, so enumerated types, that's something that we're going to be using. Object wrappers, I'm going to go through fairly quickly. Object wrappers and auto boxing, that's something we're going to come back to. So I'm going to go through it fairly quickly, but I still want you to at least understand the basics of that. The other main thing is defining your own classes. So let's get going with that. Okay, so enumerated types, what the heck are they? Well, you've read about them, and hopefully we'll kind of show you how to do that. Wrappers and auto boxing. The main thing, the structure of a class and these UML class diagrams. The book uses sort of the official one. I like to use kind of a modified one. We'll see how that is. If you prefer the books one, that's kind of fine too, but okay, let's start with enumerated types. Okay, what the heck are they? What these go back to is a programming construct where you might have a certain fixed set of possible values that, and you want variables to take on one of those four values, or in this case four, but one of those finite number of values, but not other ones. So the Java came up with this idea of Enum. Well, actually C came up with the idea of Enum, but their implementation was kind of flaky. So in this particular, like in one example, supposing we have a model that's going to be using season, and so rather than having some magic number that says if it's a 1, then it's winter, if it's a 2, it's spring, etc., we define an enum, which under the hood is really a class, but it's really another type. And the advantage of doing it this way is that when we define, in this case, a season to consist of these four values, then only those four can be assigned to a variable of type season in this particular case. So once we define it, we can use it as a type. Remember, Java is strongly typed, so every variable must have a type, and so we can use that as a type for a variable. And then we can, the way we assign it as a value is the same dot notation that we were using for methods, except now we're referring to a particular one. So in this case, season had winter, spring, summer, fall. And so we can take the time variable and assign it to season.fall. You may be wondering, okay, why go through all this? The type safety is kind of the key on this. Before enumerated types, and even if you're using C type enumerated types, which you don't worry about that, but they were not type safe, because what they actually were is they were just integers. And so the problem with that is that if in this case, in the magic integer type, let's say that we defined winter to be 0, spring to be 1, summer to be 2, fall to be 3. And then when we defined a variable of that type, though, we could assign any integer. We could give it a -5, we could give it 20. And so that was very fragile. In this case, we can only assign these four values to the season. Okay, so that's very valuable. Now, one of the things that can be useful is to find out kind of what its ordinal value is. What is that? That's simply an integer, though, and this is kind of a callback to the original use of these as integers. So we can figure out which ordinal they are. So what is that about? Each value of the enumerated type has an integer assigned to it, which we can get with a method. And it has a name, etc. Okay, so let's sort of see what this is about here. Okay, the way that you, okay, okay, so here's an example. And supposing we wanted to represent the 4 suits in a standard deck of playing cards. So here's how we would define it. We would declare it in a named package somewhere. And so instead of saying public class suit, it would be public enum suit. And all we do is we just list the possible values. And how would we create one of these? Well, again, we can right click on our package and choose Java enum. And if it's not there, again, we can pick it out from one of these. So if we were declaring a new one, we could, like if we wanted to do our season, we would declare it that way. And then our season, we would okay, so and there we have it now. And now having to define them this way, we can use them just as described. So let's look at this suit thing that we had. And now you will notice in the class code, I have defined a sub package called cs2173.run. And the idea there is to separate out the template classes from the main classes. So here, here's just sort of a test of the suit. So here are some ways that we can do it. We can set a variable to one of its valid values. So here we declared a variable, in this case called suit. That maybe I should have called it hearts, but anyway, now in order to do this, there are a couple things I needed to do. First, I needed to import the class itself. And then if I wanted to use the value in an unqualified way like this, I needed to have a static import. And the thing is, if NetBeans really helps out with this. So if I didn't have this, and notice I get red squigglies here, can't find symbol, can't find symbol. If I simply right click and say fix imports, then notice that it gives me the options here. And then that's what produces these imports. Okay, now we can also, there's a static method in each enum called value of, and what we can turn a string, if it matches exactly, then we can turn a string into the enum. So that string matches the string for spades, and so that will work. Or if I want to get all of the values, then I can get an array of these things. Now, we haven't talked about arrays here, but in your previous languages, you have used arrays. So you know what an array is, and you know you shouldn't be shocked by any of this stuff. This is how Java defines arrays. Again, we'll circle back to delving into what arrays are all about. But for now, based on your previous languages, this shouldn't upset anybody. And this is how we can show what the different ordinal values are. So when we run this, we see that, okay, so here is the hearts here. And this says, and notice I'm using printf as I like. So we have a string and an integer number here. So we see that hearts has ordinal 2. Now we can figure that out from looking at the definition of the enum, because it goes 0, 1, 2, 3. But the thing is, we can't really refer to, we can't sort of turn that easily into one of these enums. We actually can, but it requires using this array here. But that's enough. So here, spades. Notice that we actually got spades, and it had this ordinal. It is case sensitive. So if for some reason I had a string that did not exactly match, this is going to be an error. Okay, so it says, and it will, this is one of the good runtime errors. Good in the sense that it tells you exactly what the problem is. It says there's no enum constant spades with this lowercase s. So if we, okay, so that is the questions. Okay, moving along. I'm going to briefly talk about wrapper classes. Now we've seen the, where are you here? Why are you not giving me my pen? All right, so we've seen the different types of primitives, and each primitive has a corresponding object type. And since we will only be using some of these, we will be using integers. So int primitive has a wrapper class called integer, capital I. Long has a wrapper called capital long. We won't be using floats, but double has, again, notice lowercase versus uppercase. Primitive class, and Booleans. We'll be using Booleans. Occasionally, we'll be looking at chars when we start unpacking strings a little bit. So there are a number of different ways of doing this. So just like any other object, integer is a class. We can create a type of a variable of type integer, capital I, and because it's an object that's not a string, we have to say new integer. In this case, this will produce an object of type integer, the wrapper class, whose value is 40. And now, when these were first introduced, there was a problem, because if you wanted to use this in a computation, you had to unwrap it, which people got annoyed with. And so after some complaining, Java said, okay, we're going to have something called auto boxing or auto unboxing. And what that allows you to do is, basically use one of these objects in a place where the primitive would have done. Now, why? The main reason for this has to do with what they mentioned here, containers. We're going to talk about containers because they're very important. And the way that Java implemented their collections framework was that they cannot contain primitives, they can only contain objects. And so these wrappers became kind of the key for that. Now, the other thing is that these wrapper classes also have a bunch of static methods and static variables that can help a lot. So for example, if I have a string, so for example, supposing I have the string 42. Okay, why might I have something like this? Well, maybe I'm reading it in from a file somewhere. And maybe I'm reading it in such a way that I'm just getting it as a string at first. And I want to take that string and I want to unwrap it and turn it into an int. In this particular case, this is going to be a primitive int, not a capital int. The parse int does exactly what it says. It parses the value and returns a primitive int from that string. There are other useful constants, like for example, integer has min value and max value, and that holds the largest and smallest integer values. The double wrapper, for example, has, in addition to that, has things like not a number. It has positive and negative infinity, and a bunch of other useful things. Now, what autoboxing is this is what Java introduced after people complained about these wrapper things. So the idea is that you can kind of, in almost every case, you can use a wrapper or a primitive in the particular context. So for example, this is legal. So we define OBG to be an object of type integer. Num is a primitive of type int. Now, normally this syntactically, this doesn't make any sense. Syntactically, this quote shouldn't work, but thanks to autoboxing, it does work. So what this will do is, under the hood, this will take this integer and turn it into a capital. It'll take an int and turn it into a capital integer. So under the hood, it creates the object and then assign. So this will work. This will absolutely work. And then the reverse also works as well. So are the assignments values? So here we have a double wrapper, and we're assigning it to a primitive double. Or here's another one where we have a character wrapper, and we assign it to a primitive character. Does that work? And the answer is yes. So under the hood, it will take this primitive, it'll wrap it up into and stuff it into the value. Okay, so that, and we're not going to, I'm not going to use that just yet. We're going to circle back to these wrappers when we start talking about collections, which is, again, as I said, an important topic. Okay, but really the main one that I wanted to get to as soon, I was hoping to get to this a little sooner in the class, but user-defined classes. So this class, in addition to Java as a second language, is also about object-oriented design. And that involves, we design classes, which are templates for objects, and then we instantiate those objects both from the user-defined classes and the built-in classes. We have seen some of the built-in classes so far. We've seen strings, we've seen scanner, and then we've seen these wrapper classes. So those, and then as you may have understood, there are literally thousands of other classes in the built-in one. When you develop a program, it will typically have many different classes. And the program, the execution of it consists of instantiating the objects, telling the objects to send messages to each other, which is meaning, how do you send a message? You invoke a method. Okay, so how do we define a class? Well, there are basically three main core elements that are going to be in every class. And in addition, there are some static things that we'll kind of see. But the key things are instance variables. The book somehow likes this word attribute. I prefer the term instance variables. Instance methods, these are the behaviors, and then one or more constructors. Now, we will be, one very nice way of describing the class without having to revert to code are these UML class diagrams. So these came about because, well, people wanted to be able to design or describe a class without having to worry about the code. So here's an example. So, and this is partly modified from the book's example. Okay, supposing we wanted to represent a 6-sided die. So this would be the UML diagram. And it has a number of different parts. So one would be the name of the class, and that goes in the top. Now the next is, so here in this particular case, there's a class variable. In the book's example, they define it as an instance variable, but this, in this context, it's actually more, it should be a class variable. And if there's a class variable, my convention is to underline it to indicate that's what it is. So the instance variable is there. Now in the very top part, we just have the name. In the next section, we have our variables, and any other variables that we would be defined would be included here. And then in the bottom section are the methods. And one would be the constructor. That's kind of optional, and when we delve into constructors more, we'll see why that's kind of optional to put the constructor there if it's a 0-argument constructor. Okay, in this case, we have 2 instance methods. The book had a third one, which is in my view, a very bad design in that particular one for a variety of reasons. But okay, so there are 2 instance variables. One is we can get the face value, which is going to be what how many dots are showing currently. And then another one called roll, where we're going to kind of generate what that is. And then finally, we'll circle back to this, but there's a special method called toString, which every class has. And in this particular case, we want to override that, and that in our UML diagram is going to be indicated by an italic. Okay, so in our die class, max was defined as a class variable. I did not, in my, the book defines a mutator, or what I prefer to call a setter, for face value, and that is not a, well, basically what that does is that allows you to set, it's like if we're rolling a die, this allows me to say, well, I don't like the value that it was, I want to set it to something else, and that is a bad design. Okay, so let's, okay, I'm going to go over by a couple minutes just to be able to show this to you. I hope that's okay. Okay, so here's how we take the UML diagram and turn it into a class. So again, when we create not a Java main class, but just a regular old Java class. So here's the class die. Here's our class variable max, which was 6. Here's our instance variable face value. And then this is, again, a slightly better design in the book. The random is better designed as an instance variable that we instantiate in the constructor. Okay, so the constructor is something, it looks like a method, but it has the same name as the class, and unlike other methods, it doesn't have a return type explicitly. And when we delve into constructors, we'll see why that is. So when our roll here, we want to roll and return the face value like that. So here's the main method for that. So here's how we use that. We would instantiate. Here in this case, we're going to instantiate a couple of them. I'm going to have a sum. So here I'm rolling 2 dice. So I roll them both. I get the sum as the sum of their 2 face values, and then print what that is. And then I roll them again, and I do the same thing. So when I run that, we see that our first roll, and it's going to be different every time, because in the die, I instantiated random with no arguments, which means it's going to use the system clock. So in our first roll, we had a 3 and a 6, which sums to 9. The second row, we had a 1 and a 2, and that summed to 3. Okay, so that's how you use define a class, and we use it. And now Monday is a holiday, but for next Tuesday, I want you to read chapter 4, the sections 4.2 to 4.5.